Alright, so this video is about Venn diagrams. First of all, a Venn diagram is a graph made of two or more circles contained in a universe that is used to show relationships between sets. A universe, let's talk about what that means. Basically, if I created this box here, this box would be my universe. It's all the data I have, and this is what we're saying all the data in the world is, as far as we're concerned. And usually the Venn diagrams involved in there, maybe a set A, a set B, maybe a set C, and they're usually overlapping somehow, some way, but they don't have to. All right, so you have all the data in A, B, C, all the ones that conjoin between the 2 or 3, and all the people here would be the people who are in the universe, but not in any of those sets. All right, so that's what it usually looks like. Now let's actually talk about a word problem with it. All right, so I'm going to erase this note. So if you need it, I'll copy it. It's about to go away. All right, so this is the question. A survey, well, this is the data. I haven't asked the question yet. But anyway, a survey of 100 college students, and that's misspelled. But anyway, a survey of 100 college students who frequent the reading lounge of a university is revealed through the following results. 40 people read Time, 30 read Newsweek, 25 read U.S. News and World Reports. That's the name of the magazine. There's not two magazines. 15 read Time and Newsweek. 12 read Time and U.S. News and World Reports. 10 read Newsweek and U.S. News and World Reports. And 4 read all 3 magazines. All right, so to answer this question, we'll start off with my universe. I'm called this U for my universe. And in this universe has 100 students. All right, so it's kind of nice to know. So we put that number there because it told us we have 100 students in this universe. And then we have set A. Let's set A be Time magazine. And then the second set be Newsweek, NW. And then the third set, so that be U.S. News and World Reports. All right, so that's all the data we have. And let's actually start writing in things we know about it. I would always start from the one that contains the most first. Then I would go to all the ones that overlap. What I mean by most, like the most overlapping part. I would start from the innermost part first and then build outwards. It's just best to do that way. So instead of starting here with the 40 time readers, it's going to cause problems. So start here. The 4 read all 3. So this is all the people who read Time in this circle. All the people who read Newsweek will be in this circle. And all the people who read U.S. News and World Reports in this circle. And this is the section where all 3 overlap. So if anybody in this section will read Time, they'll read Newsweek, and also read U.S. News and World Reports. And that group is 4 people. So I know this section right here is 4. All right, so that part's gone. The next thing I want to go up is 10 people who read U.S. News and World Reports. All right, so the people who read Newsweek and U.S. News and World Report, there are 10 of them. So here's my Newsweek section. Here's my U.S. News and World Report section. I'm looking for where they overlap, so I'm looking for this section. Now, I know it should be 10 people here. However, 4 of them are already being used in this piece of that section. So this whole bubble here is 10, and 4 are already used because they're also reading another magazine, Time. So I consider that. So when they say 10 people read Newsweek and World Report, they're including the 4 that also read all 3. So that leaves with only 6 people left who are reading just the 2, but it's 10 if you include all those. You know, that's how you can represent 10 of those. All right, so I use this data, I use that data. The next one we want to use is the fact that 12 people read Time and U.S. News and World Reports. All right, so that's true. So here's Time, here's U.S. News and World Reports. So the section overlap is right here. And in that section, there should be 12 people. 4 people have been accounted for here. So it only leaves 8 people left. And that gives you a total of 12 people within this little bubble right here. It represents people who read Time, U.S. News World Reports, and all. Well, anyway, that's it. That would be 8 people left for just both of those. So that's left. The next thing up is 15. So it's 15 people who read Time and Newsweek. So here's Time, here's Newsweek, and the intersection between there is these two. So I need 15 people in this section. 4 has been used, leaving with 11 left there. So if I add those two up, it should be 15, and it would be 11 and 4 would be 11 and 4 would add to be 15. All right, so I use this back. All right, then it said that 25 people read U.S. News World Report. All right, so in this whole bubble, there's 25 people reading it. So I have to include the ones I've already counted. So this is 4 and 6, that's 10, that's 8. So that's 18. This whole bubble must include 25, so that's 18 gone, leaving with 7 people left who read just Newsweek and nothing else. I'm sorry, U.S. News and World Report and nothing else. All right. 30 people read Newsweek. All right, so here's my Newsweek people. And this whole bubble should have 30 people in it. So you got 11 here, 4 there, so that's 15. 6 here, that's 21. Leaving 9 people who read Newsweek alone. And the last section is 40 people reading Time. So the people reading Time is 40. So this is 11 and 4, so that's 15 plus 8. 8 and 15 is 23. So 40, subtract 23, 17. So these 17 people just reading Time magazine. All right, and the last thing is how many people left in the universe? Remember, there's 100 people in this whole universe, and all these people are readers. So if that's true, I know that I'm going to add up all these people, all these little sections to figure out how many people are reading magazines. So 17 plus 9, 11, 4, 8, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it's all of those. You add those together. All right, that's 62 people who read a magazine. At least one magazine. So there's 62 people who are reading here. That leaves you with, well, 100 subtract 62. It's 38. Leaves you with 38 people left in the universe who don't read any of those magazines. All right, so this is my Venn diagram. I'm going to stick with this, and I'm going to use it to answer any other questions about this problem. All right, so I'm going to actually give you questions about the problem now. So I'll pause the video and copy down anything that you find noteworthy. All right, first question says, how many people read at least one magazine? And it's pretty much a question we already answered. It says at least one magazine. So all these people read at least one magazine. So we added it up earlier, and that was 62 people. Next question is, how many people read only Newsweek? So if that's true, the people who only read just Newsweek, it's here. Just 9 people who read just Newsweek, because the other people read other magazines other than Newsweek, along with Newsweek. So the answer there is 9. And the last question says, how many people read exactly one magazine? So if that's true, if they read exactly one magazine, it means they don't read any other thing but that magazine. So that would be 9 plus 11, plus 17 plus 7. So 9 plus 17 plus 7. So it's 33. So it means 33 people read exactly one magazine. All right, so that's one example involving a Venn diagram. I'm going to erase this and create a new one, and maybe you can answer some of your own. All right, so pause the video and copy down anything you find noteworthy. I'm going to erase this screen. All right, last example. All right, so in a group of 40 students, 22 are taking algebra, 18 are taking biology, 14 are taking chemistry, 9 are taking algebra and biology, 7 are taking algebra and chemistry, 5 are taking biology and chemistry, and 2 are taking all 3. How many students are not taking any of these courses? So I'll start off with my universe. In this universe, how many students are there? Well, they told us in the beginning, it's 40. Are 40 students in this whole universe. And then I want a group for my algebra students. Make my bubble bigger. I'm going to use the A for algebra. And then I'm going to make a group for my biology students. B for biology. There's going to be a group for my chemistry students. All right, chem for chemistry. All right, so again, I would start with the innermost part first. And that would be 2 students taking all 3 courses. So the intersection of all 3 is here, and this is going to be 2 students. And then going backwards, it says 5 students are taking biology and chemistry. So the biology and chemistry group is here. This is where those 2 bubbles overlap at. And 2 are already being used. It leaves you only 3 left for that whole bubble to be 5, where those 2 classes overlap. All right, so that's been used. And 7 are taking algebra and chemistry. So here's algebra and chemistry section. And in this section, there are 7 students. So there's 5 left that have now already been accounted for. All right, so that's been used. And then 9 are taking algebra and biology. So this is the bubble for, this is algebra and this is biology. This is the bubble where they overlap. 9 students are in there. 2 are used, leave you 7 here. And then this is used. And then 14 are taking just chemistry. So here's my chemistry class. And of the 14, I have 5, then another 5, so there's 10 used, leave you with 4 left. And then biology, so that's used. And then 18 are taking biology. So here's biology. I got 7 and 3 is 10. That's 12. So I got 12 students already accounted for. Leave you with just 6 more students left. And the last group, okay, so this is used. And 22 are taking algebra. So in algebra, I got 7 and 7, so that's 14. And there's 22 in all. So I think it's 8. So there's 8 students left to give you a combined 22. All right, so now we figured out all the bubbles. The last thing we want to know is who's left in the universe that's not taking any of those classes. So I'll add up all these. So it would be 8 plus 7 plus 6 plus 5 plus 2 plus 3 plus 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so that's all the numbers. And we get a combined there that equals to what? So it's 35 students that are taking a class. So there's only 5 students left in the universe who are not taking any of those classes. All right, so anyway, that's it. And I just want to talk about some notation stuff just for a minute. So pause the video, copy anything you need, and see if you can understand, get this notation stuff. All right, actually I'm going to save that notation stuff for the next video. Right here, pause the video and see if you can answer this question. Pause the video, create your own Venn diagram, and see if you can answer it. And in a minute, check back with me and see if your answer matches mine. So again, pause the video now. All right, so here's my universe. In this universe, 100 customers. And these people order mushrooms, and these people order pepperoni. There's only 2 bubbles here. And it said the 60 people ordered both mushrooms and pepperoni. So that's true. If 80 had mushrooms, at least 20 people for that section of the bubble who had just mushrooms. At least 12 people, because 72 people ordered pepperoni left in that section. A says, how many people ordered mushrooms but no pepperoni? That's 20. B says, how many people ordered pepperoni but no mushrooms? So that would be this section. That's 12. D says, how many people didn't order either? So I add those up, 20, 60, and 12, and that leaves you with 8 people left who didn't order any of those toppings. That's it. That's all I have.